Good morning. So today we are going to start with the DIAC characteristic of the last point which we have seen, that is the triac. So all are just concentrate over here. So whatever the screen in front of you, so that is nothing but the DIAC characteristic of SCR. Is it? What? Yes. Is it a SCR? It's a triac, but they are just saying okay, okay. That is all. So be here attentive that this is the mere characteristic of triac. So it is just look like the same as that of the SCR, but what is the main difference between the SCR, the triac, and the next device which we are going to learn, that is the DIAC. So that we should know at a first stage. Then it's a function and then it's a application. So like that we're supposed to just study the step by step these all the power devices. So if we will just go through the history what we have seen in the last session. So we have gone through the 4 modes for this triac. That is, as we know that the triac is having how many terminals? Triac is having how many terminals? 3 terminals, MT2, MT1 and gate. So, and is it a bidirectional or unidirectional? It is a bidirectional. So the way of triggering the triac is either you can give the positive gate current or negative gate current, or the another way is by using the voltage. If the voltage is just crossing the VBO, what is that? BO stands for break over, BO. If it is in a first quadrant, then it is VBO, break over voltage. And if it is a third quadrant, so that will be breakdown voltage. Got it? So if that will be in negative direction and this will be in a positive direction, it will be there. And accordingly, these 4 modes we have gone through. So they all modes are with respect to MT2. If you have observed, either MT2 is positive or negative, and the gate is positive or negative, like that. So these 4 combinations are being made. The ultimate is that in 2 modes the current will be in one direction, and in 2 modes the current will be in reverse direction. So in that way it is going to be work in positive half cycle as well as for the negative half cycle. But is it working for the total 180 degree or part of that 180 degree? Because we know that the positive half cycle is of 180 degree and negative half cycle is of 180 degree. So it will work for the whole 180 degree or a part of that. So that is going to be decided by the gate current. After what time the gate pulse is been given. Because we know that the pulse instead of that pulse, that triac or the SCR is not going to start. So that is going to be done. So in the next session we are going to see that the waveforms, how it is actually going to be work. If you are giving the gate current at a practical level, it is mostly been explained with the properly. So the 4 modes we have gone through. So this is one additional, I have just added the slide over here so that you can observe the same 4 modes whatever we have seen in the last session. So that is the same or explained in this one. So first diagram, it is just shown the 5-layer structure of triac. 5-layer structure of the triac. And in the second figure, it is shown that if MT2 is positive, how the current is going to be happen. So it is just divided into these 2 ways like this. So the right part and the left part. So left part is that if your MT2 you are keeping as a positive, that is forward bias, and the right part, that is MT2 if it is the negative, that is the reverse bias. If you are doing the current flow, just that you supposed to find out the direction. So as I told that in 2 modes it is going to be in one direction and for other it will be reverse. So if MT2 is positive, it will be from MT2 to MT1, because we know that here it is MT1. And if the MT2 is negative, that is reverse bias, the current flow will be in a reverse direction. So here, one thing we supposed to observe is that even though it is a 5-layer, we are calling it as. So here, if you will see the current flowing through this the particular thing in 4 layers only, in either mode, and this P1, P2, that is going to be changed. So that you're supposed to observe in this diagram. So that's why I have added this particular slide. So this particular diagram, it is of total 5-layer diagram, and this one, it is a working mode. So in the first working mode, that is when MT2 is positive, MT2 is positive, through which layer the current is flowing, that may be asked in the MCQ question. So it will be P1, it will be N2, it will be P2, and it will be N5 or N4, sorry. It is not this one, it is in this direction. In this way, the current is going to be flow if the MT2 is positive. And if you will see, that is the next one, that is if MT2 is negative, then the current, definitely this will be the positive. So that time the current is going to be start from P2. So this P2, it will be goes through the N5, then N3, then P1 and N1. Because the MT2, it is connected with P1 as well as N1. MT1 is connected with N4 as well as P2 also. So that we supposed to check out. Because if you are remembering this structure, the negative terminal of one and the positive terminal of other. So they are connected to each other the same way on the either side also. So that is what this is the structure for this track we have already studied. So this is how all the 4 modes, and this is the way of flowing of current. So this 4-layer analogy we are supposed to just note it down, and we have to observe also. If MT2 is positive or the forward bias, the current will flow through P1, N2, P2 and N4. And if it is the reverse, so current will flow through P2, N3, P1, N1. So in that way. So the right hand side, if you if it is tedious to draw the diagram, so you can write in a wording. If MT2 is forward bias, if MT2 is forward bias, current will flow through the layer P1 dash N2 dash P2 dash N4. P1, N2, P2 and N4. Case B, when MT2 is reverse biased, MT2 is reverse biased, current will flow through the layers P2, N3, then P1 and N1 in this way. Lastly, we have taken this gate, but it is of no. So these 4 layers, it is going to be used. And from that, this is the DIAC characteristics is prepared from the readings. So this is also the, if you will observe the same one, the working is also same one, but only just we have to concentrate is here is that whatever this, it is started from the 0 point, So up to here, is the triac is on. Just change the color. So whatever red I am just showing, so you're supposed to give the answer from earlier explanation. So is the triac is on or off? It will be off. And when it crosses this particular VBO, so current is going to be start flowing in this way. And that is the same for the opposite way also. Up to here, it is off. So what is this? What is this? The arrow I have shown, that the margin. What is it? It is a leakage current. So few leakage current is going to be start. So in this way, in both the direction, the triac is going to be made high. And this is the IH. So that is also important. Up to here, even though it is crossing this particular, so up to here, below the holding current, the triac will be off. So that is also additional. We're supposed to just make it. This is a positive IH and this is negative IH. So here only it is going to be made on the triac. So why to make this triac on, off, on, off? So it is to be regulate the AC devices. It is to regulate the AC devices or the power control of this particular AC. So the various applications now onwards we are going to look of. So this is what the another way it was shown, that is the VI characteristic. So we have seen in the last, that is to here. So here at the junction, it is IG is equal to 0. We have not applied the IG, so this curve will be there. But if you apply the IG, if you apply the IG, so this will be curve like this. If you will increase the IG, if you increase this particular the IG, so it will become like this. Got it? So whenever you are increasing the IG, IG means gate current. So VBO, that is the breakover voltage, is increasing or decreasing? If IG is increased, VBO for triac will be decrease or increase. From that graph only you can understand. गेट करंट जर वाढवला तर VBO म्हणजे की ट्रायक ऑन व्हायचं व्होल्टेज हे कमी लागेल का जास्त लागेल? IG 0 आहे त्यावेळेस VBO एवढं लागत होतं. IG 1 इथे आहे. So it requires the less. जर मी IG 2 वाढवला तर अजून VBO कमी होणार. IG3, because the relation it is mentioned over here, IG3 is greater than IG2 is greater than IG1. जसं मी गेट करंट वाढवत जाईल तसं व्होल्टेज लागणार ते कमी होत जाणार. आधीच लवकर फायर होणार that triac. So in that way we supposed to just look for this particular VI characteristic. Otherwise the earlier characteristic, this one and this one, it is the same one, but only in this characteristic or the diagram the additional things they have shown, that is if I will increase the IG, what will happen. So any of VI characteristic you can draw, no issue. So if in detail, so this one will be, I will prefer. Otherwise the earlier one, that is the simple one, that is. But in this some additional matter is also written, that is this is the on state, SCR1 conducting, MT2 positive, SCR2 conducting, and on state, and MT2 negative. So So you can combine the major things from both the diagrams, and you can prepare your own VI characteristic for DIAC. Here in this, the IH they have shown, that is the holding current. That is also very important parameter. The next diagram, it was not mentioned. So you can combine the good points from both the diagram, and you can make it your final VI characteristic for DIAC. The online student, you can also have to draw this particular VI characteristic. If the diagram is over, I will ask to randomly to anyone from online student. So they're supposed to show me the notebook. All of you be ready. Okay, roll number 44. Abhishek, are you there? Okay, so
Yes, sir.
make your video on and show me your notebook.
Sir, I haven't written.
You have not written. Okay, we will have a talk afterwards. Roll number 3. Sanjana madam, are you there?
Yes, sir.
Can you make your video on and just show your notebook?
Sir, not written. Sir.
Not
अजून
written.
notebook आणलं.
Notebook अजून आणलेलं नाही.
हा.
Then I will talk to your parents, madam. No. Next one, 28. Pratibha.
Yes, sir.
Madam, can you make your video a little bit on and show the notebook?
नाही सर.
Can I? You also don't have the notebook. Deepa, madam.
हा सर लिहिलं नाही.
नाही, नोटबुक तर केली आहेत का?
हा केली.
तेवढीच तर दाखवा मला. लिहिले जाऊ दे. Let's make your video on and show me the notebook at least.
सर मी गावाकडे आली.
तुम्ही गावाकडे आलात. So the notebook is not with you. Madam, from the first lecture itself, I am insisting to all the students that you, even though you are attending, this is online, so it is compulsory that your notebook should be with you. It should be up to date. So when that 100% offline it will be there, that notice will come in a few days. So that time, what you are going to do? You are taking casual. I don't know. Just I called to your parents also. They are also saying okay, they are attending and like that. And you are just telling ki गावाकडे आले आणि इकडे आले. So that reasons are not good, madam. So you only just I am insisting to all others also. Roll number 38, Omkar, are you there?
Yes, sir.
So have you made the notebook?
No, sir.
No, sir. Why? Any reason?
No, sir, because I am working on farming. That's why not a time to write. Taking screenshot only.
You are farming.
Yes, sir.
What is your native? From where you are?
Sir, I am Magaleda from Magaleda.
So the whole day you are farming only, is it?
No, sir. Little bit working.
Little bit working also. So take one day exclusively for our college side and visit to college. So it is not
Okay.
far away. So we will have a talk.
Okay, okay, sir.
So it has been observed that the maximum student has not made or they are just taking casually as that of the earlier online session were there. So we're supposed to take some action against them also so that it a positive action so that they can take it seriously and not as a formality. Okay, but as the offline students are taking the benefit of that, I'm just seeing the notebooks also they have prepared and maintained also. Okay, so with this we will go ahead. Okay, if the VI characteristics you had drawn, so this is what it has been written in the working mode. That is an explanation for this the VI characteristic. So it is working in a first and third quadrant. So MT2 will be positive or the negative. In that way, it is going to be work. Another way that is it is also possible to turn on the triac below VBO. Means VBO will be the only one voltage. And below that, if you want to trigger the triac. So what is the alternative? That give the gate pulse. So that is what it is written by applying a gate pulse in such that the current through the device should be more than the latching current of the triac. We have know that the holding current and latching current. Latching current is minimum current above which the triac will be on, and the holding current the maximum current we can say below which the triac will be off, because if it crosses the holding current it will reaches to latching current, and if it crosses the latching current the triac will be on. So that is the just to remember. Similarly, when the MT2 is negative, that is the first case, this is the another, and this is the opposite one. That is MT2 is made negative with respect to MT1 that we have gone through. So advantages of this particular triac over this particular the SCR. So main advantage, or we can say the comparison point between the SCR and the triac. So SCR is a So that in next slide we will see in a quiz. I have just put that question, so I am not giving the answer over here. So as compared to this, the anti-parallel heat sink. So anyone heard this word heat sink? Gone through. Okay, what it is? Heat sink. Okay, write down somewhere heat sink, and in the last session also I think one diagram I was shown and shown that what is this metal part. So this is what in the next unit we are going to discuss about this. So this DIAC is going to be work that is add in advantages, that is for AC devices as well as in DC applications also it is going to be used. The disadvantages are also every devices will have the advantages as well as the disadvantages. So according to your application you supposed to choose the device. So what is this? The lower rating as compared to the thyristor. That is the at lower frequency only we can use this particular triad. And a careful consideration is required while selecting a gate trigger. Okay, 9 has tried to do itself saved around the component folder. Okay, find out the answer. Okay, very good, madam. So afterwards also in detail we will have a discussion on that. So what the other disadvantage the triac has? These have low dV by dt rating as compared to the thyristor. Thyristors here it is the SCR. What is the long form of SCR? Sorry, once again. Silicon controlled rectifier. The word it is there in the rectifier. So what is the rectifier is doing? That converts, that is the AC into the DC mainly. But here no such word is there in triac, because in this triac it is going to be work for the AC as well as, and the SCR it is having the limitation. So it will just convert into the DC only. So that is the one of the, we can say, your internet connection. What happened? Am I audible, online student?
Yes, sir.
Okay, fine.
Yes,
So,
not a problem.
okay. Another disadvantage of this triac is these have very small switching frequencies. That is the frequencies, whatever it is there. So they are working is a very less frequencies. Triac are less reliable than thyristor. So what is the meaning of this reliable? How they have taken, don't know. But less reliable means we can prefer the SCR if you are going to be used instead of this the triac. So definitely this reliability is depending on the parameter, that is the power saving or the power control. So whenever the question comes, that is to power control the AC appliances. So that time SCR also can be used, or this particular triac is also going to be used. So that time if it is the high power motor or the high HP motor, it is going to be there, and that you supposed to regulate it. So that time this particular less reliable than this particular the other devices of this thyristor family. So they are the few disadvantages of this the triac. Application, that is due to the bidirectional control of AC, triac are used as AC power controller, fan controller, heater controller, triggering devices for SCR, and 3-position static switch. So all these applications you can search for few of them in the next unit we are going to learn. So what is this light dimmer and this fan controller? We are not going to see the concept. We will see that is the heater controller. That way we are going to learn, but the other so many applications are there that you can search on the Google. So you will get the in detail the circuit diagram and it's a working, how it is going to control this particular electrical appliances. Why it is electrical appliances? Because electrical appliances are working on a AC. So that's why we are just insisting the. Okay, so this is all about this particular the triad. So I will stop the sharing. So for today's session, we will start with this particular the production part and the last bit from the first unit, that is the DIAC, construction, working and the VI characteristic we are going to start now. But before that, few quiz questions for you all. Just take 1 minute and try to build the answers for these questions. Online student also, you can keep your answers ready. If your answers are ready, you can put in the chat box. Roll number 9. Let's try to give the answers for these questions. So for that, you can refer the earlier slides also, or the whatever the diagrams you have drawn in the notebook, if it is there. So first question is asked in this slide, that is the DIAC is a unidirectional device. True or false, it has been asked. DIAC has dash dash layer analogy. That is what we have studied. So that is been asked over here. Next, that is the working mode. It is the question related with. When empty2 terminal is positive with respect to empty1 and gate is positive with respect to, it is not written here, but what it may be, gate is positive with respect to whatever the modes diagram we have seen. So from that, it is expected the answer. So if online students are unable, so I will ask to the offline student.
Sir, first is false, sir, because track is a bidirectional device.
Okay, very good. Next.
Track has a 5-layer analogy.
Okay.
6.
Okay, here only we are getting that is the 2 answers. Okay, we will see. And third. So here the via dash dash layer. So the count it is not expected. So the layer names it is expected, because at the start of today's session we have gone through. That is which layers are going to be utilized during this particular the working modes. So one of the mode they have given in this, and they have asked through which layer the current will flow. So that layers step it is expected to write over here. And the fourth one, that is SCR, is bidirectional.
True, sir.
True. Okay. Okay, now I will ask the same, that is a offline student. The third, I have asked one question. That is when empty2 is positive with respect to empty1 and gate is positive with respect to empty1 itself. Okay. The current flows via the layers. So have you written the layers? So before at the start only we have gone through. So this is what the answers are. So see that the layers. Now this P1, N1, P2, N2. So I referred to some other diagram where the layers naming is different I have given. So it may be in the morning we have seen the different one. So due to that, this is going to be mismatched. So there is a conflict on the question, but the answer may be the correct of yours. So that way only we can see. So first answer is false, second is the 6th layer, third one is this one, and the SCR it is the bidirectional, it is the false, it has been given, because majorly it is having the control for this particular the rectifier. So it is going to be work, that is AC to DC. So it is also having the one conflict, because somewhere it has been added that it is a unidirectional only. So from that, this particular question it is written that is the false, bidirectional it is not there. Okay, so we will get it done that the answer the correct. So whether to write the F or is it a unidirectional or bidirectional, the SCR. So can we have a debate on that? The SCR is unidirectional or bidirectional. That is whatever we have learned over here. The current is flowing in both the direction or single direction. Single direction. So from that, it is having this particular, that is the statement is written what? SCR is bidirectional. So it is false. So in that way, it is mentioned over here. So all has to take a note here. 34 is writing that is it is true and bidirectional. So just take flow of current as we have discussed right now, that current is flowing only through one direction in the SCR. So not a triac we are talking about. So just take care in this way. Triac 5 layer we have studied.
Yes, sir. 5 na.
5. Okay. 5.
हा सर 5 असले ट्रॅकला.
Okay. Yes. I think I have miswritten this the answer over here. So just make this correction also here. So here it is the 5 layer analogy we have seen for the triac. Please use for the triac only. Yes, for triac only. So make this correction for the answers. Okay, so let us move ahead with this particular the DIAC. So for triac we have seen the long form is triode for AC. So in the same way, the DIAC, it stands for diode for AC. AC means alternating current. So two diodes are connected back to back, useful for AC power control. It is a bidirectional and it is mostly used in triggering the triac and thyristor based circuit. So all the brief summary it is mentioned in this slide about the DIAC. The DIAC starts conducting electric current if applied voltage goes beyond breakover voltage. DIAC don't have the facility of controlling by the gate terminal. So what is the meaning? So when we will see the symbol or the structure, all these statements will be come to know. So this is the symbol for the DIAC. So two diodes are connected back to back to as shown in this particular diagram. That is anode and cathode of other is connected, and that will be treated as a one terminal. So here also, here they have shown MT1 and MT2. You might be showing here the MT2 and here MT1. So depending on that, the flow of current and all that is going to be decided. So don't get confused that it is a fixed one is here. So any one terminal can be replaced. Or the names are also we can give terminal 1 and terminal 2. So that may be possible. But the standardization they have given, that is the MT1 and MT2. So this is the symbol for the DIAC. So if possible, so draw in the notebook also. Now here again the conflict question. The DIAC is made up of 3 layer, 4 layer, 5 layer. So any construction can be made of this particular the construction of this DIAC, either 3 layer, 4 layer or the 5 layer structure also. But here we have taken or the 5 layered structure only. The layer closer to the terminals are a combination of both positive and negative. So from here, this is positive and this is negative. So from that it has been made. It is negative, it is positive. So they are connected to each other. When the voltage passed to the terminals, the layer with respective polarity to the voltage gets activated. So when this particular, this will be positive and this will be negative, the current flow will be in this direction. When this will be positive with respect to this, the current will be in reverse. So it is a bidirectional device in this way. So in this slide also, so in detail, it is shown that the 3-layer, 4-layer, and 5-layer analogy for the DIAC. So if the 3-layer, by using 3 layers only, if the manufacturing of DIAC is been done, so this will be the first one. If the 4-layer, so it will be middle one, and if it is 5-layer, so it will be the last one. So like that. So any one of can be used and construct the this particular DIAC. That is the using of these two diodes. So in the 3-layer, there will be 2 junctions, and it will be simple PNP. So it is just like your transistor. But what is the difference in this one and your transistor? So here 2 terminals are there. In transistor, 3 terminals are there. That is no base is here, like that. So here it is the PNPN structure for this, the DIAC, and here it is 5-layer analogy. So 1, 2, 3, 4, and 5. But when you are going to be connected again, here they have written A2 and A1. We have written MT1, MT2. So don't get confused in that. Anyone you can use. So even though it is a 5-layer, so whenever you are connecting in either MT1 with respect to MT2 positive, 4 layers are only get involved in the flow. So how that the working mode we will see in the next slide. So this is very important slide. That is the 3-layer, 4-layer, and the 5-layer structure for the construction of DIAC. So here we have considered the 5-layer structure for explaining the working modes. So the 2 ways are there for as a working mode for DIAC. Either MT1 is positive with respect to MT2, or MT2 is positive with respect to MT1 in that way. So here you can see this is the first diagram, that is when MT1 is positive and this one MT2 is positive. So when MT1 is positive, the current flow will be downward direction, and when MT2 is positive, the current will be in upward direction. So in that way, you can just check out, even though it is a 5-layer, 1, 2, 3, 4, 5, but during this current flow, it is just using P1, N2, P2, N3 in this direction. And in a reverse direction, when the current is going to be flow, so that time you can observe it is starting with this particular P2, N2, P1, and N1. So only 4 layers are getting involved in this particular flow of current. It may be either downward direction or the upward direction. So out of 5 layers, only 4 layers are being involved in this particular flow of current. And at the same time, what is this junctions? So they are fixed. First and third, they are in forward bias, and the middle one, that is the reverse bias always. So as you are increasing this particular voltage, so this reverse bias, that barrier is going to be get vanished, and current is going to be flow in either of the direction. So it is the working mode of this particular DIAC. In 2 modes are there. That is this one. MT1 is positive, MT2 is negative. So current flows through this one. So it can be asked in the MCQ. So that type of sentences must be there with you for DIAC also. If you want, you can just note it down. This 2 working modes for DIAC. Let us see that these layers and whatever you have drawn, so they are matching or not. Just check out. Was P1, N2, P2, N3. P1, N2, P2 and N3. Okay, with respect to this diagram only, this layers it has been mentioned. P2, N2, P1, N1. P2, N2, P1, N1. Okay. With respect to this diagram only, the path is written. So whatever the layers you have shown, so check out that one. So, red mark in this brown mark. So if it is over, we will go ahead. The next part is that the VI characteristic of DIAC again. So again, if you will observe, it is also look like the same one as that of what we have seen for the TRIAC. But the main difference is for DIAC, there are only two terminals. No gate terminal is there. That is gate control. That facility is not here in the DIAC. So it is also working in the first and third quadrant. That means if you will apply the voltage across MT1 and MT2. So if it crosses the VBO in first quadrant, the current will get surge. And in the reverse, that is, if it is the opposite one, so third quadrant, if it crosses this particular the breakover voltage, negative breakover voltage, the current is going to be surge like this. So this is what up to here leakage current, and when it crosses the VBO, the current will get high. The same way, that is the negative direction up to here leakage current, and after that it will get a quick increase in this particular the current in opposite direction. Okay, the current, it has been shown with the polarity negative one, but just for showing the direction only, this negativity is going to be used. So this is how in a first quadrant and a third quadrant, the DIAC is going to be work. So this is the on state, the blue shaded it is being shown, and this red shaded it is will be the in a off state only. So that also we are supposed to observe. So again here, what it may be? It is a holding current limit they have shown in a positive direction, in the negative direction also. So if that crosses this particular the current, the DIAC will become on. Okay, so if you want, just draw it roughly this particular. So as we have seen in the triac, IG1, IG2, IG3, that concept is not applicable in this one. So how to make the DIAC on, or when the DIAC will be get on? Only if it crosses the VBO. That is the only one way of making the DIAC on. With the title VI characteristic of DIAC. is over, we will check out what is remain. Yes. Okay, if it is over, we will move on. Afterwards, you just complete it. The last part of this particular device, that is the advantage, disadvantage, and the applications for it. So it is of a low cost. That is the first. We can say that is the advantage. In every device, you cannot add this advantage. For the SCR also, it is a low cost. For track also, it is a low cost. So you're supposed to just compare, and accordingly, it is mentioned over here. So it is used for the low power application, smooth control of power that can be switched on off just by lowering the voltage, because it is working on a low voltage only. Then what is its disadvantages? That is, it is a low power device. So for low power applications only, it is going to be utilized. It only conducts when voltage increases above 30 volt. So that is also we supposed to note it down somewhere. VBO, as we said that if voltage crosses that VBO, so VBO for DIAC is 30 volt. Means compulsory your voltage should be more than 30 volt to make the DIAC on. This is the limitation. And it cannot block the high voltage. It is requires the minimum 30 volt, so it cannot block the high voltage. So that is also one of the disadvantage of DIAC. So again, there if you will see the applications, heat control, trigger the DIAC, light dimmer, and the DIAC control flasher. That is the on off of this particular LEDs and the other things. So they are the few applications of the DIAC. So few of them, also one or two, we are going to learn in the next. So this is what the practically we had conducted in the last year. So I have taken from that. That is how this particular LED can be get blink by using this particular the DIAC. So for that, this particular the AC supply has to be given the two diodes that has been used for the rectifying all this, and it is going to be work out. And how much the for measuring the voltage, we have add the voltmeter. So that practical also we are going to conduct. Okay, so this is all about the first unit. All the contents we have covered. So you just go through that. I will stop sharing the contents. If anything is missing or some doubts are there, you can just go through it. We'll stop over here. I will take the attendance. Roll number 1, 2, 3 is here. 4, 5, 6. Roll number 6, 8, 11, 14, 16, 20, 21, 22, 24, 25, 26, 27.
Yes, sir.
I asked 27 only right till now. 29, 31, 32, 33, 35.
35 is present, sir.
So here 41, 43, 45, 46, 47:48. 47 where we went. Okay. Thank you. For the next session, don't miss the session and as early as possible join the physical college.